This is Module 6. It discusses measurement and estimation. Please subscribe and share it. Also be mindful of the bell-shaped button. You must press it so that subsequent presentation will be sent to you digitally. Thank you very much. It is important for researchers to collect data and obtain responses from field respondents, which should be measured. These responses are to be measured for the purpose of analysis. Responses can take the form of real numbers or qualitative attributes. So what is measurement? Now, measurement is the assignment of numbers or qualitative attributes to objects, events, or other characteristics of objects according to some specified rules. Now, there are two broad measurement categories. Before we go to the rules of measurement, let us examine the two broad measurement categories. One, measurement of intensive qualities, which is basically for qualitative measurements. Then measurement of extensive qualities, which is for quantitative measurement. Now, for the qualitative measurements, there are two categories or two conditions. Two conditions are possible for that. One, you can say A1 is greater than A2. That sounds quite normal. You can also say A1 is less than A2. That's also good. You can also say A1 is equal to A2. Those are the three main ways by which you can express yourself, by which you can express the responses when measuring intensive qualities. Now, the second condition, you can also say A1 is greater than A2. Supposing A1 is 15 and A2 is 12, you can say A1 is greater than A2. Supposing those are your responses. If those are your responses. Now you can say A2 is greater than A3. A2 is 12 according to our example, and A3 will be less than 12. Anyway, that's what it means. And you can now say A1 will be greater than A3. So if you use those figures, 15 to represent A1 and 12 to represent A2 and 9 to represent A3, so such that A1 will be greater than A2 and A2 will be greater than A3. So taking A1 now to be greater than A2, 15 is greater than 12. Taking A2 to be greater than A3, 12 is greater than 9, which is A3. A1, which is 15, will also be greater than A3, which is 9. This is a rule of measurement. If you draw any measurement rule that is not in compliance with this, you may be getting more measurement errors, which are not really desirable for your analysis. Now we go to extensive, which is largely qualitative. For extensive, you can say A1 plus A2 is equal to A3. So assuming that A1 is 15, A2 is 12, then A1 plus A2 is equal to A3. That is the rule. So 15 plus 12 will equal to A3, which is 27. That is how it's to be fashioned out, because these are real numbers. When you add 15 to 12, you must get 27. There is nothing again that you will get other than 27. Now, Another one is this: if x is equal to y, let us take x to be 14. If it is equal to y, it means y will also be 14. Then 14 plus x plus z, you know x, y, z. If you are going to have z again, 14 plus z should be greater than y. So 14 plus whatever z is should be greater than y. It can't be less again, because z cannot be 0. You know, so it must be greater than 14. Then another instance: if a is equal to x and b is equal to y, then a plus b should be the same as x plus y. This is another cardinal rule that must be followed in your measurement. Then the last one, but not the least: if you have bracket a plus b, close bracket, plus c, that should be equal to a plus bracket b plus c. These are the major rules that have to be followed when you are, you know, assigning numbers or qualitative attributes to objects or events, or when you are drawing out characteristics of objects should be according to these rules that have been set out. Now, measurement can be done by scaling. Measurement can only be done by scaling. A scale is a method of measurement. So you have to draw out a scale for attitudes, for opinion, for behavior, and other qualitative characteristics. You have to use different scales for them, and the most popular is the Likert scale. Factors of the phenomenon must be logically interrelated. There must be logic in drawing out the scale. You know, it must follow, it must be sequential. There must be logic. Factors of the phenomenon must be logically interrelated. Then this will depend on its continuum and must be reliable. It must be tested to be reliable, because if it is not, then you cannot draw out the necessary information you require from the respondent. Types of measurement scales. Now, I can have measurement scales for opinions. Usually these are qualitative scales, qualitative measurement scales. For opinions, for attitudes, for behavior, and other quality characteristics. Whatever happens, the rules of measurement must be upheld as much as possible, and I have said before, the scale must be reliable. These scales are available, among others. If you go to the provided link, the link provided, you can check out the scales for further reading. But the major ones are: one, nominal scale. This scale consists of two or more named categories into which individual objects or responses are classified, and usually the classification or categorizations are distinguished by their attributes. Dimension is not important here, you know, and the nominal scale has no origin, it measures no distance, and has no order. It could be in form of yes and no, you know, or yes, no, undecided, gender or sex, religion. If you examine this, you will see that although they are classified, but no distance, it didn't start from anywhere. No one is higher. It's just this categorization you see are just labels. You know, they have no origin, they have no distance. Distance between yes and no does not exist. Between male and female does not exist. Between religions does not exist. And there is no order. You can put no first, yes later on, yes first, no later on. The numbers you assign to them are merely labels. You can call yes, you can say yes means 1, no means 2, undecided means 3. You can play around with the numbers. They are just labels. They are not real numbers. Then the statistical tools that you use majorly are chi-square. They are, statistical tools that don't have any concern for real numbers. Contingency coefficient, percentage, mode, crosstab. And statistical parameters are usually mean rating scales and frequencies, because the figures you got are labels, they are not real numbers. So you cannot be talking about mean, median even, so you have to use mean rating scale, or a scale that is based on what is it called? I've forgotten. When you scale it, you rank it, a scale based on ranking, because no real figures are involved here. Ordinal scale. Ordinal scale assign numbers to indicate only relative positions. The scale gives rank to the individual along a specified continuum. This is what is called ordinal scale. It is also possible to categorize them. They have order, however, they have other positions. They measure no distance anyway between positions. No origin. For example, good, fair, bad. Strongly agree to strongly disagree. If you examine this, you will see that they are relative positions. Good, fair has gone down a bit, then to bad has gone down to the lowest level. Strongly agree, coming down to strongly disagree. So they have relative positions. Statistical tools that are amenable to that include ranking, median, mode, Spearman's rule. Statistical parameter, you can also use mean rating scale, frequencies, ranking, mode, median, Spearman's rule. The third one is interval scale. Two persons with scale positions 5 and 6 are as far apart as two persons with scale positions 12 and 13. However, a person with scale position of 12 cannot be said to be twice higher or better than a person with a score of 6. So the main features are that intervals remain equal. A temperature of 100 degrees Celsius cannot be twice as hot as 50 degrees Celsius. It has order of position, it has distance, but no specific origin. It can start from anywhere, but their intervals are equal: 31 to 35, 35 to 40, 40 to 45, and so on. Statistical tools amenable to interval data include t-test, f-test, Spearman's correlation coefficient, and statistical parameters include mean, mode, median, standard deviation, and so on and so forth. The ratio scale incorporates the properties of an interval scale together with a fixed zero point or origin. In other words, the ratio scale has origin or 0 point, which the interval scale does not have. The interval scale can really begin from anywhere. From the previous example, you saw that it began at from 30 to 35, not from 0. But the ratio scale has a 0 point. It can begin from 0, or it's often starting from 0. So in addition to order and distance, it also has a 0 point origin. Examples of ratio scale are weight, length, time, and so on. One can compare both differences in scores on the basis of the ratio scale and the relative magnitude of scores. So you can compare differences in scores. For example, the difference between 10 and 15 is 5. So for instance, let's use time, because time is also on the ratio scale because it has origin. The difference between 10 minutes and 15 minutes is the same as between 15 minutes and 20 minutes. Then we can also say that 10 minutes is twice as long as 5 minutes, or 10 minutes is half as much as 20 minutes. The major tools that are used for ratio scale are t-test, f-test, and so on, because they are measured in scores, in real numbers. Then statistical parameter that you can use includes the mean, geometric mean, harmonic mean, percentages, variation, standard deviation. Then you can also use median. It depends. You can use median. And now we go to rank order scales. Rank order scale is a comparative and relative rating scale in which you use to rank. So rank order scales rank individuals in relation to one another, from the highest in the scale to the lowest. It will also provide a mean rating value to do the ranking. In other words, when you get a mean rating value, you can now rank according to that score of the mean rating value. You can say the first rank, or the one that ranks number 1 is this, the one that ranks number 2 is this particular component, and so on and so forth. Like that, you can get the ranking. So this kind of ranking is called the rank order scales. Now let us consider the summated Likert scale. It consists of usually Likert scale consists of a series of statements to which the respondent is to react. The respondent indicates the degree of agreement or disagreement. For instance, if what you are measuring is approval to a particular response, to a particular query, then you can start from, you can label disapprove 1. You can say disapprove strongly is 1, disapprove 2, undecided 3, approve 4, strongly approve 5. Or alternatively, you can say strongly approve 1, strongly disapprove 1, disapprove minus 1, I suppose. Sorry. You can say strongly disapprove strongly minus 2. You can say disapprove minus 1. You can say undecided 0. Then approve plus 1. Strongly approve plus 2. It depends on how you want to label, because these are just labels, they are not real scores. As I said before, under the qualitative labeling, they only label attitudes and opinions and so on. They are qualitative measures, which we call intensive attributes. They are intensive attributes. So at the end of the day, each total score of a respondent is found out by summing up his different scores for different responses. That's how you find the total score. At the end of the questioning, you now sum up all his responses based on the scores attached to the different responses. The total scores will now indicate his position on the continuum. So it is used in the measurement of social attitude. I mentioned that already. Likert scale taps into intensity rather than extremism in position. So it sort of measures intensity, disapprove, strongly, disapprove. So there's an intensity there, you know. One is more intense. Disapprove strongly is more intense than disapprove. The same way, approve is less intense than strongly approve. So it measures intensity rather than the positions, the positions 1, 2, 3, 4, 5. No, it doesn't measure positions as such. It measures intensity in the attitude or in the opinions, so that at the end of the day they are aggregated to know the total score that will indicate the respondent's position. Examples of Likert scale is given on your right hand side, and you can see for so many measurements. If you are measuring importance, so you can say not important, slightly important, moderately important, important, very important, for example. So along that continuum, it measures intensity. The study of measurement is incomplete without considering the errors that can arise from measurement or field observation. So these errors can arise when you are taking your field survey, or your questionnaire, when you are taking responses from the questionnaire for your questionnaire. They can arise from poorly worded questions in the survey. If your question is poorly worded or your questions are poorly worded, it is not impossible. That is, it is possible for respondents to misinterpret the questions and give you wrong answers to your questions. Then, 2, incorrect recording of a response. If after you got the response and you recorded it incorrectly, measurement error is likely to occur. Then you might record correctly the respondent's inaccurate response. Maybe the respondent responded inaccurately, but you recorded it accurately. Anyway, it's still an error. And why the respondent will respond inaccurately may be part of one above, which is poorly worded question, or if your diction is not very clear, the response can be inaccurate even though you recorded accurately. Then, misunderstanding of the scaling approach. The respondents may not understand your scaling, and it may likely scale incorrectly. It is possible. So you have to be very clear and specific about how you intend to scale your approach, so that the respondent can fully understand this. That is the necessity for reliability analysis. That helps you to check whether they truly understand your diction and what you are asking them, whether they are likely to give you correct answers based on the questions you are asking them. In any case, they don't give you correct answers, then your outcome will be nonsense, because it will not address your research question. Neither will it address your objective or your aim of study. Incorrect application of a statistical method. For example, when you use a non-parametric statistics when you should have used a parametric. So your results are not likely to be correct, and your interpretations will also be wrong. The 2 components of measurement errors are the random errors. You can make random errors. You can also make systematic errors. Random errors, they are naturally occurring errors that are expected with any experiment. For instance, you use a spring balance to measure maybe in the sun, and this instrument expands as you continue to use them and they are giving you wrong readings, or maybe certain conditions of loading and unloading which are affected by natural factors, So you can reduce this kind of error by averaging over a large number of observations. So the best way to reduce this kind of errors is to make your observations very large, or your sample size to be very large, so that the errors can ease out. So it's a natural occurring errors. Well, not due to any fault of yours, but because of certain errors that are inherent due to weather conditions or other conditions beyond your control. You could also have systematic errors when your instrument is miscalibrated or faulty. So all your measurements are affected. For example, if your stopwatch shows 100 seconds for a natural time of 99 seconds, everything you measure with this stopwatch will be distorted. So, and you can also reduce this kind of errors by trying to identify the source of the error and removing it. So a common design for reduction of measurement error is a reliability analysis. In reliability, what we do is to take a sample of your bigger sample, take a part of your total sample, and administer your questionnaire or your questions. Then when you get returns, you try to analyze it to see whether they satisfy your requirements in terms of the answers or responses you are expecting. And for this, you could use the chromatographer and other methods as well. So you need to check and recheck, because once you start making errors from the beginning, the errors will follow you through, and your outcome may not be reliable at the end of the day.